We might not notice, but tremendous technology and mind-boggling science constantly surround us in the products we use every day. Behind their practical use lurk hidden histories, dramatic discoveries, and awesome experiments. They are Wicked Inventions. Coming up, forklift trucks. Why is a huge weight crucial to its success? Gravity. Why can a lack of it cause toilet problems for astronauts? Handbags. How a historical lack of pockets led to the development of this female favourite. We reveal the surprising science and amazing manufacture behind these wicked inventions. Forklift trucks are today a must-have piece of machinery for any warehouse or factory, making the carrying and loading of goods, tools and pretty much anything else much easier than it ever has been before. But how exactly was the forklift born?
Forklift trucks is one of those kind of inventions where necessity was really its mother. Around 1917, the Clark company in the USA developed what they called a truck tractor, which is basically there to assist in moving things around their factory floors, their warehouses.
This truck tractor soon caught the attention of everyone in the business as they recognised its great potential to ease heavy lifting and therefore increase productivity. Heavy industry was experiencing a boom in the early 20th century, and this truck tractor was seen as the perfect tool to complement a new industrial world.
At some point, clients were brought in obviously to see their goods being moved, transported, making sure, and a lot of clients started to ask Clark's to create a truck tractor for them, so they commercially started to produce them a couple of years later.
However, the truck tractor was quite limited in the heights it could reach, and so new technologies had to be implemented that meant it could reach much higher. Coincidentally, around the same time, developments in hydraulics as well as much progress in machinery using hydraulic technologies meant that this became an obvious solution for the truck tractor's limited ability to stretch.
And it was the Yale company in the 1920s created what was kind of effectively the first real forklift, which could elevate boxes, crates above the height of the vehicle for the first time. The truck tractor was a bit more vertical, so you would only be able to really go as high as the vehicle, but this way it allowed it to get higher.
This added height that hydraulics gave these new machines saw the birth of the forklift as we know it today. When World War II began, forklifts became a huge part of the war effort, helping load ships, airplane hangars and much more. The forklift really came into its own in the 1950s as warehouses began to expand upwards in an attempt to save space. Their ability to reach up high proved invaluable. Since then, forklifts have been continually improved upon, with safety features being added such as a cage for drivers that prevented falling materials from injuring them, as well as detachable and interchangeable forks that can be used for a whole range of purposes. It's fair to say that today's industries probably couldn't manage without their trusty forklifts, which certainly makes them one wicked invention. But how exactly are they made? Yale is a leading manufacturer of forklift trucks. At their manufacturing plant in Craigavon, Northern Ireland, it takes 4 days to make a forklift truck from scratch. And they have the capacity to make up to 100 forklift trucks every single day. Coming up, we'll find out why balance is crucial in creating a fully functional forklift. But first, the production process of a forklift truck starts with the raw materials. Sheet metal arrives at the factory and shapes are cut which will form the forklift chassis. A laser cutter is used to cut the metal, which cuts to an accuracy of 0.01 of a millimeter. The metal shapes are then taken to the sheet press, where the pieces are bent into shape for the chassis parts. Next, the metal parts of the chassis are welded together to create the basic form. Then the frame is transferred to a robotic welder, which does the majority of the welding and secures all the seams to construct the chassis frame. This takes around 45 minutes for each frame. The chassis frames are then loaded onto a rig, which carries them through to the paint process. The parts are powder coated.
Here in Craigavon, one of the things that we're actually proud of is the actual finish of the forklift trucks that we make. All our forklift trucks are powder coated, and we use an e-coat system that actually gives our product a very high shine finish.
After this, the engine, powertrain and transmission are all assembled by hand, before being installed into the chassis frame. An integral part of a forklift are the overhead guards. This is a strong cage structure which offer the operator protection from falling objects. The guards are welded together in the shop and then painted before being attached to the forklift chassis with bolts. Hydraulic valves are tested and attached to the dash plate. Controls, pedals and steering column are all assembled in this process. The dashboard is then attached to the chassis frame. A crane is then used to lift the assembled chassis frame of the forklift onto the rear axle. An electrical torque tool is used to bolt them together to a specific tightness. After this, a special tyre robot is used to install the tyres onto the axles. Machines like these and automated guided vehicles, also known as AGVs, are becoming more widespread as they increase the manufacturing efficiency of the plant.
Over the next 5-10 years, we'll be introducing a number of new products into the Craigavon facility. And as part of those introductions, we're looking at new automation, we're looking at collaborative robots, we're looking at different ways of actually moving material, using AGVs, etc. So future designs are all based around trying to make the product more efficiently, increase the automation that we use, and make it more ergonomically friendly for an aging workforce.
Next, all of the electrical and hydraulic connections are made. The hydraulics are used to power the lifting equipment. The engine cover and the seat are installed and fixed into place. At this stage, the truck is driven off the assembly line. To allow the forklift to lift large, heavy loads, a counterbalance is used. This hefty weight is positioned at the back of the truck and literally holds it down, keeping the balance in the centre of the forklift to prevent it falling over when a heavy load is raised on the forks. Once the counterbalance is attached, the mast can be installed onto the front of the truck. It is the mast that drives the forks. Its tracks allow them to move up and down and from side to side. One of the last steps is to attach the most important parts of a forklift truck, the metal fork assembly. A fork guard is attached first. This guard is called the load backrest. It helps to support the load, and in the raised position, it stops the load falling back over the overhead guard in order to protect the operator. Then the forks are lifted into place using a crane that uses very strong electromagnets to pick them up and lift them into position. The machine is then tested to make sure it can lift to its designed capacity and height. Branding decals are applied to the truck before final quality checks and testing are performed. Finally, the brand new forklift truck is delivered to shipping for dispatch to customers worldwide. The forklift, truly a wicked invention. Gravity. It stops us from spinning off into space and makes apples fall from trees. But coming up, we're going to find out why a lack of it spells trouble for an astronaut's bladder control. But first, what exactly is gravity? The answer? No one really knows, but we have built up a pretty good idea of how it behaves and the influence it has over our world and space.
Gravity is a force of attraction between two items. It's a bit like having two magnets. As if you take magnets and as you bring them closer and closer together, nothing seems to happen, but when they get very close, they suddenly snap together. That's essentially how the laws of gravity work. It's an inherent property of mass. So anything that has mass has its own gravity, but it needs quite a lot of mass in order to have a lot of gravity.
If everything, including people, causes a gravitational field, why are we not constantly being pulled into each other? On a gravitational scale, the gravity generated by our bodies is virtually negligible, so we don't notice its effects. But what if you are looking at an enormous object, such as a large planet or star? Objects this large generate enough gravitational force to seriously influence other objects around them. Indeed, it was the observations of early astronomers and mathematicians such as Galileo in the 16th centuries who realised the effects of some kind of force could explain the motion of planets. But what were the laws that governed this force? It was left to Sir Isaac Newton in 1687 to create a mathematical formula which attempted to calculate the gravitational strength between planets.
What he worked out is that the force of gravity is equal to the gravitational constant, the mass of the two bodies, whatever they are, divided by the distance between them squared. What this means practically is, the heavier an object is, the greater the force of gravity. If the distance between them is doubled, the force of gravity drops by a quarter. So gravity, as you get closer and closer to something, increases quite a lot. And as you get further away, it also drops off very fast.
Gravity affects life on Earth in many ways. The Earth's gravity pulls on us and keeps our feet on the ground. The atmosphere that protects us from space and allows us to breathe exists because gas molecules are kept in place by gravity. The changes in sea levels, known as the tides, are due to the slight bulge created in the oceans as the moon pulls on the water as it orbits the Earth. Gravity even affects how much you weigh. As the moon has 1/6 the gravitational pull of the Earth, you would actually only weigh 1/6 of your weight. This is why the Apollo astronauts could take great leaps as they walked across the surface of the moon. So, gravity is just a force of attraction then? Not quite. In 1915, as part of his theory of relativity, Einstein stated that gravity wasn't a force at all. He said it was a distortion in the shape of space-time. What does this mean? Instead of gravity pulling on a particle and changing its direction as it travels through space, as described by Newton's law, Einstein believed that a large object's mass actually bends space and time itself. So the object is still travelling in a straight line, even though it may appear to be orbiting another larger object.
Imagine a trampoline, and you put a heavy object on it. It bows down nicely into the heavy object. If you put another heavy object somewhere else on the trampoline, you now have 2 points where it bows down, but between the two, it's more of a pronounced dip. This is what's called the fabric of space-time. It's a mixture of space and time. If you take something that moves around the main heavy object, the place that requires the least amount of energy to be lost from the object, bearing in mind as it drops towards the bigger object it loses energy, is in a circular motion that if you took it apart you would find is a straight line. So if you imagine the movement of a planet, it's like moving around the contour lines on a map. Trying to keep on the same contour line, there's almost no energy expended, and planets can move, and planets can move for years, millions of years.
We can use this bending of space and time to our advantage. A satellite's orbit works because of a balance between two forces. The orbit is a combination of the satellite's velocity, the speed it is travelling in a straight line, and the force of the Earth's gravitational pull on the satellite.
In the International Space Station, for example, what you have to remember is that the International Space Station is always falling towards the Earth because of the way it changes direction. So it means that astronauts in space, in orbit around the Earth, are always technically falling towards Earth, even though they appear weightless, because their speed around the Earth is such that they don't fly away from Earth, because the Earth's pull against them is such that it balances out and they are weightless. It's a cancelling of forces.
Whilst this clever balancing of the forces of gravity and velocity can be used to the advantage of the International Space Station, the lack of gravity on board can make an astronaut's life rather uncomfortable. For instance, on Earth, the gravitational effect of urine in our body triggers stretch receptors that line the bladder to tell the brain that we need to relieve ourselves when it is about a third full. In space, the lack of gravity means that urine does not collect at the bottom of the bladder, meaning the bladder can get dangerously full without the astronaut feeling the urge to go to the bathroom. To combat this, astronauts are told to pee every 2 hours. So, from creating galaxies to letting you know when to go to the toilet, the understanding of gravity really is a wicked invention. Can we make water cheat gravity? we're going to need a wine glass, a handkerchief, a tray, and some water. We drape the handkerchief over the glass and push the cloth gently down into its centre. We fill the glass 3/4 of the way up with water. We gently pull the ends of the handkerchief down so that it is stretched tightly across the glass's top, and we grip the ends of the cloth on the bottom of the glass. We are now ready to cheat gravity. With the tray ready to catch any drips, we quickly turn the glass over. The handkerchief stays in place and there is no water falling out of the glass. Even though we could pour water through the holes in the handkerchief, when it is stretched tightly across the top of the glass, the holes become so small that water molecules bond to other water molecules to create a thin membrane called surface tension, which cannot pass through the holes. We may be trapping water rather than cheating gravity, but it is a fantastic science trick. Can we make water cheat gravity? Yes we can, sort of. Wicked challenge smashed. From the earliest stages of civilization, handbags have been strongly influenced by technological and societal changes such as fashion, jewellery, and even mobile phones. But just how were they introduced?
It all evolved over time, largely because of dress, but also different materials, as different clothes evolved, as different fastenings evolved. People have often needed bags to carry things around, and so historically people would have had small pouches to carry things. They often were just kept to keep coins in and personal items as well.
Pouches were worn by men as often as women, as only a small amount of trousers actually had pockets.
There were also other kinds of bags that were sort of part of the history of handbags, and they were actually carried around in the sort of 16th and 17th centuries. But rather than keeping your coins or your personal belongings in, they actually kept smelling salts or herbs, spices, flowers as a way of warding off disease.
Years later, during the Industrial Revolution, the invention and mass production of new materials meant that bags, purses, and even pouches were easier to make for the modern traveller. This was when we began to see the handbag as we know it today.
One of the major revolutions was the railways, the travel. So you started to have people travelling and they needed bags to put their things in. This included luggage, but it also included what was a separate handbag that was separate from their main luggage. And that's really where the term handbag evolved from.
Leather document cases and plastic carrier bags were then created, making mobility with personal belongings and shopping even easier. We have also seen the rise in branded bags, with many loyal customers buying the latest designs to add to their collection. The variety of handbags has now given fashion enthusiasts a wide choice, in hope of finding the perfect balance of practicality and style. Handbags, truly a wicked invention. All of these stylish leather clutch bags are made by hand in this workshop in Folkestone, England by Steve Harkin.
I started making handbags about 40 years ago, playing around with leather as a part-time job. I established the brand name Stephen Harkin Design in 1996. Since then we've been through a series of events, and now what I do is I only sell directly and made to order, whereby a customer can choose, for example, a design they like, and then they can choose the colour combinations, etc.
The production of one of Steve's sought-after bags begins at the clicking press. Firstly, the leather for the bag is selected and laid out onto a cutting table. A specially made blade shaped to the relevant component parts of the leather is then selected. These blades work like heavy-duty cookie cutters, cutting the leather to their exact dimensions. This blade is placed on top of the leather and the clicking press presses down with the impressive force of 1.5 tons, and the leather is cut to size in an instant. These blades also have incorporated in them all of the cuts, nicks and pins of the catches and folding lines, which will come in handy later in the production process. The newly cut leather is then skived in a bell knife skiver. It guides the selected edge of the leather across a rotating, razor-sharp blade. This blade thins the leather at the edges to allow for later gluing and folding to create a crisp, folded edge and to reduce bulk. After the skiving is complete, it's back to that clicking press. Felt backing is applied to the back of the leather. This felt is self-adhesive and instantly adheres to the leather. The press is then pressed down onto the leather and backing to permanently fuse them together. Because the leather is quite soft, this backing will serve to ensure the bag keeps its shape and sturdiness for a very long time. The skiver is then used to take some of the newly applied reinforcing away from the edges of the bag. Again, this will make the glue bonding stage easier when the bag comes together. It's over to the embossing machine next. The embossing machine heats the logo and presses it into the leather of the bag. These little marks left by the cutting blades make sure that it is embossed in exactly the right place. The logo has to be heated first, as this type of leather responds to heat and will ensure that the logo is permanent. Next is the first sewing process. The suede leather inner lining of the bag that has also been cut to shape using a clicking press is ready to have its zip fitted. First, using a combination of glue and sticking tape, the pocket lining and zip are assembled. This is then sewn using the sewing machine with nylon thread. The catch is then fitted to the bag and a small bit of reinforcing fabric is placed on its back to increase the strength and to make sure it doesn't move. With the catch attached, the leather lining is fixed to the inner shade lining by gluing and accurately lining the two parts up. A clip is then added and the outer leather is then folded over neatly to hide any seams. This is all then placed back under the clicking press once more. First, the press applies pressure to bond the inner and outer leathers.
It's like a shoe glue. It needs to be set with pressure, and then it will probably never come apart.
Another cutting blade is then placed over these now fixed parts to cut them to an even neater finish.
So this final cut blade, what it does, it takes about 3 millimetres off all around the edges, and it means that the lining and the leather outer are perfectly matched.
With this stage complete, the freshly cut edges are coated with a black edge coat. This is an acrylic that seals the leather. These edges are then run over a hot soldering iron to smooth everything out and seal it once more. Our bag is nearly there, but it still doesn't quite look like a bag. Firstly, the flap of the bag is sewn. The edges of the body of the bag are then glued and folded precisely. This gluing stage ensures the bag stays in place when being sewn.
Because I make so many different styles, tomorrow I'll be making a different type of bag altogether. So I glue everything in place so I know that when I get that to the machine, it's not going to move and I'm going to get the same result every time.
With this, the final sewing can take place, and just like that, the bag is complete. The handbag, a fashionable and very handy Wicked invention. So, there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing backgrounds. Forklift trucks, gravity and handbags. All Wicked inventions.